Alright, I want to talk about square roots, which is kind of a new thing in 7th grade. I don't think we typically deal with them before, but the idea here is that if we take, say, a square, and what we know about squares is that their sides are equal, and the area of a square is equal to s squared. So if my side here is 3, that means I know the other side is also 3. And my area is going to be equal to 3 squared, or 3 times 3. And that's going to give me 9. And these numbers, where we can square something and get to them, are called perfect squares. And they're kind of really fancy, and we use them a lot in math. And it's really important to know them, and I often use them even when I'm doing my math facts. So they're key to know. So if I take all of my numbers, 1, 2, 3, 4, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, and 10 squared. And these, I should really know all of these in my head pretty easily, because I need to be familiar with them, and especially it's important when I'm evaluating these square roots. So 1 squared is going to be 1 times 1, which is equal to 1. That's a really easy one. We don't use that very often because it doesn't really help us simplify anything. 2 times 2 is equal to 4. 3, not to the 4th power, it's supposed to be 3 squared. 3 times 3 is equal to 9. 4 squared, 4 times 4 is equal to 16. 5 squared is 5 times 5, equal to 25. 6 squared, 6 times 6 is equal to 36. 7 squared, 7 times 7 is equal to 49. 8 squared is 8 times 8, 64. 9 squared is 9 times 9, equal to 81. And 10 times 10 is equal to 100. And these are the perfect squares that we should absolutely know. And in fact, we often go a little bit higher. We do 11 squared and 12 squared. And the reason we do those is because of the stupid inches, because inches go up to 12. And it's important to know the facts using 11 and 12. So 11 times 11, I think, is like 122, but boy, I do not use that one very often. 11 times 11, 11 times 11 is 121. Close. 121. And 12 times 12 is 144. I do know that one. And these are the perfect squares that we use to figure out these things. Now, what I can ask, though, is I can go backwards from squaring, and I can unsquare something. And I could say, what times itself is equal to 64? Now, the problem with this is it's very wordy, and we wouldn't really fit this in an equation. So instead of that, we can condense this down into this symbol. 64. We say this as square root of 64. And it's kind of like an adapted division symbol, the old style of division, except instead of putting a number here, we don't need to know the number of how many goes in. I want to know what times itself is equal to 64. And this would be easy because I should know, or I can look back at my little chart I just made. Oh, well, that's 8. 8 times itself is 64. And that's what our key is for. And this is our square roots. And pretty much this section is going to be asking you to evaluate some square roots using the ones that we know. And they're also going to be asking what happens when we have a square root that is not one of these numbers. So for example, say I ask you to evaluate the square root. I think I have use the space here. The square root of 30? Well, I can look up on my little chart 30. Well, the square root of 30 is bigger than 5, but less than 6. And I can say that the square root is going to be between 5 and 6. Now, later we'll be able to find the decimals of these, but it is very time-consuming and difficult. So at this point, all I want to know is what are the two numbers that it's between. Look, one more. What if I ask you to find the square root of 90? Again, it's the same thing. I'm going to say 90 is between 9 and 10. So it's going to be between 9 and 10. That's really all we're going to be working on today. So go ahead and good luck on this section 9.1.